1.6 is titled Set Operations and Compound Inequalities. It's really this compound inequality idea, and it is a little bit bizarre, but if you just roll with it, it's totally fun. So we're going to start off by doing objectives 1, 2, and 4. So first off, we're going to recognize set, intersection, and union. So I like to show this with a Venn diagram. If you've never seen one before, don't worry, they'll make sense by the end. If you consider two sets, so we've got set A defined as the numbers 1, 2, 3, and set B defined as the numbers 2, 3, 4. In the first circle for A, we're going to write the numbers 1, 2, 3. But when we write them, we're going to notice that 2 and 3 are actually in both of the sets. So if you think of this first oval being set A, the only number that's only set A is 1. And then one that's shared by set B would be 2 and 3. Whereas set B contains 2 and 3, but it also contains 4, which is not part of set A. So this would be my Venn diagram for my set of numbers 1, 2, 3, 4. You'll notice that 2 and 3 are in set A and B, and 1, 2, 3, 4 are in sets A or B. And if you already understood that, that's the whole point of this lesson. So let's try this a bit slower. So the first thing we're going to look at is the intersection of sets. The intersection of sets is all the elements that belong to both sets. So if this is A and this is B, the things that belong to A and B would satisfy A and B. Now, intersection, okay, there's 3 words and symbols here. Intersection means where they satisfy A and B. So intersection has an N, so does the word and. So intersection means and because mathematicians are lazy, they don't want to write either of those words, they use this symbol, which is an upside down U, which kind of looks like an N. Isn't that nice? So intersection and upside down U, which looks like an and, all mean the same thing. So for example, if I wanted to know the numbers that satisfy A and B, I would say it's the 2, 3. It's the numbers that went in the middle overlapping section of my Venn diagram. So let's practice just that. So if I have set A being 3, 4, 5, 6, and set B being 5, 6, 7, what numbers satisfy A and B? Well, it would be not 3, because it's not over there, not 4, because it's not over there, 5 and 6 for sure, but not 7, because it's not in set A. So those are the numbers that satisfy A and B. All right, I want you to try it with these guys. So the numbers that satisfy A and B, you got your 5, you got your 15, and that's it. So it'd be the set of 5 and 15. So those are the numbers from the sets that satisfy A and B. Well, the opposite of intersection, or and, is a union. A union is the set of all elements that belong to either A or B. Now here we go again. Union, I know it has an N, but the most important thing here is it starts with a U, which looks like this U here. So U, union, and it means or. Now, to be or, it means that you satisfy one set or the other set. You don't have to be in both. So for my first example, it'd be anything in either of the circles. So 1, yeah, that satisfies A or B. 2 satisfies A or B, in fact, and 3 and 4 satisfies A or B. So it's anything that's in any of the sets. You just don't want to write numbers twice. So for example, in this set, like we did above, if we wanted to figure out what satisfies A or B, you want to make sure all the sets of both, or all the numbers of both sets are listed. So we'll go with 3, 4, 5, and 6. That's all the numbers in the first set. And then my second set has 5, 6, and then I'm going to add on a 7. If you like the Venn diagrams, like if they help you make sense of this, right? You've got 3, 4, 5, 6, 7. So it's anything written in the circles. You just want to get rid of duplicates. So I want you to pause the video and give this one a go. What satisfies A or B? What is the union of those two sets? And hopefully you counted by 5s up to 25. So 5, 10, 15, 20, and 25. Awesome. All right. So now what we're going to look at is compound inequalities. But you know what, before we do that, why don't we pause the video? Let's do this as one video. Why don't you go practice just that?